Good morning. This lecture is a continuation of Castigliano's theorem of minimum strain energy. In this lecture, we will apply Castigliano's theorem of minimum strain energy for the analysis of indeterminate trusses. Let's see what are the steps in this method. First step, draw the given structure with all the given structure means the given truss with all the applied loads and support reactions. Next, find degree of static indeterminacy. Static indeterminacy means internal static indeterminacy and external static indeterminacy. If the structure is externally static indeterminate, select the redundant reaction R. Any support reactions can be selected as redundant. Number of redundant reactions equal to degree of external static indeterminacy. Now, if the structure is internally static indeterminate means if the structure is having additional members, take force in any member as redundant force. If it is having one degree of static indeterminacy, then take one member force in that member as redundant force. Draw the given structure with applied loads, reactions and redundant reactions. Next, define member force P in all other members using method of joins. If the structure is internally static indeterminate, find dou P by dou T. And if the structure is externally static indeterminate, find dou P by dou R. And if the structure is internally static indeterminate, Castigliano's second theorem is sigma P into dou P by dou T into L by A equal to 0. And if the structure is externally static indeterminate, our expression is sigma P into dou P by dou R into L by A equal to 0. Next, find all other unknown forces using method of joins. Example, determine the forces in various members of the pin-jointed frame shown in figure. Length and axial rigidity A is a constant for all members. Pin-jointed frame means truss. Okay, consider truss member A, B, C, D, E, F. Okay, let the supports be at A and D. A is a hinged support, so there will be two reactions. D is a roller support, only one vertical reaction vertical to the plane of rolling, and external force is 120 kilonewton at the joint B. First, find out the external static indeterminacy. External static indeterminacy equal to R minus 3, where R is the number of reactions. We have 3 reactions, so 3 minus 3 equal to 0. So the structure is externally static determinate. Okay, not indeterminate, it is determinate structure externally. Now find internal static indeterminacy. Internal static indeterminacy equal to M minus in bracket 2J minus 3. M is the member, total members equal to 12. 12 minus in bracket 2 into J. J is the number of joints. 2 into 7 minus 3 equal to 1. That is the truss member is having one additional member. Okay. Let BG is this additional number, that is if you are removing this BG and if you are replacing this BG with a force T. Okay, T where T is the member force in BG, and let the member BG is the redundant member, that is additional member. You can select any member as redundant. Okay, take force in BG as redundant. Now our Castigliano's theorem is sigma P into dou P by dou T into L by A equal to 0, where P is the member force in different members. Okay, let T be the redundant force. Now we want to calculate member force in all other members A, B, B, C, D, etc. using method of joins in terms of this 120 kilonewton external load and this T kilonewton load. Okay, we'll consider this T kilonewton load as redundant or external load. Okay, similar to this 120. Okay, Now tabulate the result. Member length P, dou P by dou T. Different members A, B, A, G, etc. are there. Length also there. Find out the member forces in all other members using method of joins in terms of 120 and 120 means external force and T. You get all the values. Now find out first derivative dou P by dou T for all other members. You get values. Tabulate the results. Now our relation is sigma P into dou P by dou T into L by A equal to 0. Okay, that is we'll find out the sigma value of every members. Sigma of member AB plus sigma of all other members, sigma of second member AG plus sigma of member AF plus sigma of member BC. Sigma means sigma of this relation. Okay, first for AB we'll find P into dou P by dou T by into L by A plus for AG you'll find P into dou P by dou T into L by A. Okay, P into dou P by dou T. Okay, plus P into dou P dou T for this AG plus etc. We'll get 1920 minus 24T into 1 by A equal to 0. From this relation, we'll get the value of T equal to minus 80 kilonewton. That means the magnitude of force in member BG is 80 kilonewton, and the negative sign shows that this force is compression. That is, our initial assumption was this force is a tensile force T. Now we got the value negative value, so that means T equal to a plus 80 kilonewton compression. Now substitute the value of member force in BG or T in all other members. So that is for AB. Substitute the value of T, we will get the force in AB. Like that, substitute for all other members and tabulate the result. We will get the member force in all other members. This is force in kilonewton. Now second example, using minimum strain energy method, analyze the truss shown in figure where A is a constant. Truss member is AB CD. Okay, 10 kilonewton is the external force applied at D. 3 kilonewton is the length of AD and CB. 4 meter is the length of DC. 3 meter is the length of D and CB. Now find out external static indeterminacy. You will get the value 0. Internal static indeterminacy, you will get the value 1. That is, there is an additional 1 member for the truss. Let the member force AC be the redundant. Okay, that is, we are considering this AC as a redundant member or additional member. Okay, now let T be the force in this member. Okay, now find out all other forces, all other member forces, that is member force in AD, member force in DC, member force in DB, member force in AB, member force in CB using method of joints in terms of this 10 kilonewton and T. We'll tabulate the results. Now this is our relation sigma P into dou P by dou T into L by A equal to 0. We'll get 17.28 T minus 108 into 1 by A equal to 0. From this relation, we'll get the value of T equal to 6.25 kilonewton. Now substitute the value of T for each member. We'll get the member forces in A, B, B, C, C, D, etc. Thank you.